Hello everyone, welcome to today's session on deploying deep learning models in production using FastAPI and containers. In this session, we will walk through a real-world architecture for deploying models, scaling services, and ensuring the reliability with containerized environment. So why the production deployment matters? So training a model is only 10% of the work. The real challenge is serving predictions to end users. We need to ensure there should be a low latency inference, there should be a scalable infrastructure, and there should be a security and monitoring in between. So this is where fast API, containers, and CI/CD pipelines, along with that monitoring, will come together. So today, our today's session especially on for the architecture, how we can have the architecture walkthrough for this particular thing. So we have divided three things over there. So first, here the main component here is model development and training. So here in model development and training, data scientists train models using frameworks like TensorFlow, PyTorch, or scikit-learn. The trained model is then stored in some data storage or databases like MySQL, Postgres, S3, Mini O3. Okay. Likewise, it can be stored in any of these databases. Then there will be a model development and training pipeline will be there. Once the model training is done, the journey from the data scientist to model training will done. Once it is done, we will get one thing called as model.pkl format. Okay. Once we'll get this model.pkl file, we can store this model in some data storage. Okay. Once it is get stored in some data storage format, then it comes to model inference services, like the trained model is stored by a fast API application. Okay. The fast API will provide the REST endpoints and then it will predict the model. Okay. So here there are multiple supporting services for doing it, like monitoring and logging. Okay, then there is a CI/CD pipeline. So what a CI/CD pipeline means, it will automate the container build and deployment. Like for example, we'll have a GitHub Actions, which will be built on a Docker image. It will push the registry and deploy automatically from there. Okay, likewise, we will have a load balancer and autoscaler, which will distribute results across multiple inferences container, which will it will auto scale and ensures high availability under the heavy load environment. Then we'll have authentication and authorizations also. So it will protect the API calling. So only authorized users can call it. Okay. So like we will call, for example, O authentication to JWT tokens. Likewise, we will have multiple API from where we will call the authentication, and then when the user is calling it, then only it will come. Then there is a monitoring and logging part. It will track the performance and latency along with the errors. Okay. So after this, we are having again one services like load balancer and autoscalers. When it comes to load balancer, this load balancers and autoscalers ensures the incoming requests from the end users are distributed efficiently across multiple servers, which will scales up the load and increases down and increases and downs as it drops. Okay, so the scaling will, like for example, multiple servers are there. Okay, so whatever the user endpoints is coming, it will enter here, it will distribute evenly to multiple servers so that it will get evenly distributed to all the multiple servers. Likewise, we will have multiple files like monitoring and logging. Right now only we have understood, like continuously track the health, for example, failure of the machine, if the performance is not appropriate, or any uses for particular parts of the system is required. Feedback system is there for engineering and ops team. Likewise, we will have multiple things here. Once this is done, once this modeling and logging, load balancers, data will be coming here. Data will be coming from here, and we will have multiple things from here. Okay. Then, for example, fast API app, then there will be a model inference services. Model inference services will do what? We will have a fast API app, which will provide the clean, RESTful endpoints for consumers and predictions from the outside world. Here there will be multiple things like model loader. What is here in the model loader means it will load the trained model into memory from the storage or from any type of databases. Okay. And then it will supports a dynamic or a runtime model from switching and versionings. Likewise, we can use here a CPU instance. Either we can deploy locally also, either we can deploy in like cloud-based platforms also. So it depends. It executes the inference request using optimal available computation power. Okay, like hardware for a task like this. Then the end user request flow. Then the end user request flow will be here. So an end user or a calling system sends a prediction request which will pass through load balancing, security, all these things. And then once this is done, again it will be passed through the end users. Okay, whatever the predictions we have got, it will be returned back to the end users again. Okay, so let me now maybe some people might have some confusions on this. Let's demonstrate this here. So here we are having multiple files. You can see I have used a VS Code environment within which there are multiple things over here. So you can see this is our train.py file. In this train.py file, we are using this random forest classifier as a model. Okay, we are running this model, we are saving this model in model.pickle format. Okay, so the saved model is saved here in the model.pickle. Then after that, we will have our app.py file, which is here. Okay. In this app.py file, we will have, this is the fast API app loads. Okay. So this will do what? This will do what? Here you can see the app load here. The host is this. And the port number is 8000. Okay. So what we are doing means this fast API app will load the model and it will expose two endpoints. Okay, it will post two endpoint, a health check and a predict for inference. Okay, a prediction. Then after that, it uses a post, their features and API responds with the predicted results on that. Okay, and all these requirements file, all these things are there. Okay, these are nothing but whatever we have required here for installing, all these files are here. So here, once we will run this, what will happen? We will get somewhere along something like this. Okay, some message like this we will see. That message inference API is running. And we are taking this Docker file also here. Now here in the Docker file, what we are doing means this Docker file package is the app for scalable, portable deployment. Right now we are doing a deployment locally in my local machine. Okay, so it sets up the Python. It installs all the requirement files as I have shown you. Copies the application code which is present here. Okay, and the model as well, which is the model.pickle file. And then it will run using a unicorn. Okay, so once you will see here, let me show you the Docker. See, this Docker file is running over here. Once I will press here, you can see, you will get one message, that message inference API is running. So it is running over here. And if you want to check this, you can use, this is a Docker guys. Okay, I will show, like I will tell you how to download also this. So this is our Swagger. Okay, so once the file is loaded, if you want to check for any type of like sample testing you want to do. So for the sample testing part, what you can do means you can go here in the post predict section, and reset it. I have added here the features of my choice. I can change these features also, like 5.2, like 3.8, whatever, and execute this. Okay. And then what it will do, it will give us some predictions over here. The predictions are nothing but, see here, 1 minute. I want to show you this. Here in our train.py file, we have used this arrest dataset, which is a publicly available dataset. So this is a 3-class classification project, guys. Okay, a dataset. Arrest dataset is nothing but we can say a flowers dataset. I will show you. If you will see, this is a publicly available dataset. Okay, if we will see here. Oh, let me. Okay. So you can see here, this data set is nothing but a 3 array species with 50 samples each. Means this is nothing but a flower data set having 3 categories. You can see here Setosa, versicolor, and this is one class. There are 3 classes of petals and sepals. These are all the features of this data set. Okay, so there are 3 classes, and from this 3 classes, our prediction is saying that this class belongs to 0. 0 means the first class, very first class. So there are 3 classes, 0, 1, 2. It is predicting the outcome. Successful response. You can see here. It is in the form of string, and it is giving us the successful response over here. Okay. So this is it, guys. And if you want to deploy it on a cloud platform, yes, you can do that also. Okay. So first, for running this particular thing, you have to install Docker Desktop first. You have to install Docker Desktop. After installing this Docker Desktop, you have to run the container. Okay. For running the container, you have to have the code for this. Okay. Whatever I have written in this code, you have to have the code for this, for a Docker file. In this, whatever the model you are taking, what is the APP? APP is nothing but this app, wherein the fast API is connecting with this Docker. Okay. Host we are taking is our fast API host. Port number we are taking is 8000. And we are trying to deploy it on a UVCon. Okay. So using command prompt, we can use it. Okay. So you have to first install this Docker in your system, and you can run it. Okay. So I hope now, after particularly seeing this thing, it is meaningful now. So let's get back to our architecture diagram. So we are having this model development and training part. This is one part which we are doing. Okay, after this is a supporting services for load balancing, data storage, monitoring and logging, all these things, CI/CD pipeline, and then all these things will be pushed into the fast API. Okay, then all will be sent to the end users. All the predictions will be sent to the end users. Either we can deploy this on a CPU platform, or either we can deploy it on a cloud-based platform also. Okay, so it depends which we want to deploy it, which we want to deploy it also. So I hope this is understood. So if you have any queries about admissions or so on, you can just call on this number or mail us. Our support team will call you back. Thank you for joining. We'll meet you with a new topic on next lecture. Thank you once again.